Hello viewers, welcome back to my channel. I hope you are enjoying all the videos. If you have not subscribed yet, please subscribe to my channel and share among your friends. I am back with another dynamic programming problem from Leetcode today. It is the minimum path sum. We are given with MYN grid filled with non-negative numbers. Find a path from top left to the bottom right which minimizes the sum of all numbers along its path. There is a note here, you can only move either down or right at any point in time. So you are only allowed to move either down or right. So there are only two ways that can move. So the other two possible options, the left and up, are not there, right, in the typical grid. So let's go look at the example. This is a 3 by 3 array. So even though the description says m by n, right? So m and so number of rows and number of columns need not be same. But in this particular example, what is shown on the screen, it has 3 rows and 3 columns, right? So as the description says, we have to start the path at the top left. So typically that cell is called 0th cell, 0th row, 0th column, right? And we have to reach to the bottom right. So that will be the last row and last column typically, right? So in an m by n grid, that will be called as m minus 1 and n minus 1 cell basically, right? So then since it is a 3 by 3 grid here, so it is from 0 0 to 2 2. The cell will be 2 2, right? So 0th row, first row and second row, 0th row, first row and second 0th column, first column and second column. So 0 0 2 2 2, that is a cell that we have to find out the path, and we have to minimize the sum. So there are many paths possible, right? So but we need to find the path with minimum sum. So we have to return only the sum in this case. So we don't need to return the path specifically, but all we need to do is just return the sum here, right? So that's what the question asked here. So let's try to solve this with the dynamic programming paradigm, right? So for m by n array, as we talked, there are several paths possible from 0 0 to m minus 1 and n minus 1. So this is the top left corner cell and this is the bottom right corner cell. So our goal is to find out the minimum sum path, right? So let's examine various sizes of the grids, right? So if there is only 1 by 1 grid, obviously there is only one thing which is starting and ending, and the cell, whatever the content it has, that is the answer. Just go look at the 2 by 2 array. So 1 3 1 5, right? So in this case there are two paths possible. You can go, obviously we start from the top left corner, that is 0 0, and then we go either down or right, only two paths, right? So there are two possible paths, 1 3 5 and 1 1 5, right? So if you add up these numbers, right, it will be 9 here and it will be 7 here. So the answer that we are going to return is the minimum sum, that will be 7 in that particular case. So to solve this in a dynamic programming way, right, so we want to keep track of the sum at ijth cell. So starting from 0 0 to ijth cell, what is the minimum sum possible from 0 0 to ijth cell? So to keep track of the sum ending at ijth cell, so we will have m by n array, so which is equal to the array or the grid that is given to us, right? So initialize, first initialize is first row sum and first column sum. Basically the first row and first column we will have to initialize with their respective sums, and then starting from the cell 1 1, right, if at all the m and n are greater than 1, right? If it is less than 1, we are done right here, right? But if it is greater than 1, right, Then we will start with the cell 1 1, and you can reach 1 1 either from 0 1 or 1 0, right? So 1 1 is typically in our example where the number 5 is there. So you can go to 5 from this 1 or from this 3, right? So what you need to do is you need to make the minimum whatever that is happening through those two different sides, right? So you need to choose the minimum of two choices here. So once you choose the minimum of two choices there, right? So that is the minimum that is possible. So finally you will continue that logic until you move to the m-1 and n-1th index. So whatever the minimum that comes at m-1 and n-1th index, that will be the solution, right? So let's try to follow these steps, right? Let's try to follow these steps and for this matrix, right? So initially we said we are going to declare an array which is equal to m by n, right, in case 2 by 2. So we initialized all of them to zeros, and then now we are saying we should fill the first column sum, right? So first row, so 1, so that is the first element, we will fill with 1, and then 3. So the sum will be, if it has to reach from this to this, right, the sum will be 4. So the sum will be 4. And for the first column sum, right, 1, and this will be 1 plus 1 2. So that's what it is. So we by this point in time we filled the first row and first column sum, right? So now we need to fill the remaining cell, that is at 1/1th cell, right here. So you could come from 1 plus 2 plus whatever it is there, that is 5, or 1 plus 4 plus 5, right? So there are two possible things that are two possible paths are there. So the minimum is 1 is 9, 1 is 7, right? 1 is 9 and 1 is 7, whatever the content that is there here plus the current cell, right? 4 plus 5 is 9 and 2 plus 5 is 7. So we will put 7 as the minimum here, right? So this is the answer that we need to return for this array. So the minimum possible path sum is 7. So let's go implement this idea as a full set of code, right? So first things, we are going to initialize the sum array which is equal to the m by n grid, right? So we are getting the m by n, m and n values, and declaring the m by n array. So we have to initialize the first cell which is equal to the grid of whatever the input grid, and we initialized with that sum because that is the minimum possible for the first cell, right? And then we have to initialize the column sum and we have to initialize the row sum, right? First column and first row sum. So typically you add up the values and put in the first column, and you add up the values and put in the first row. So and then we will go from the cell 1 1, right? Typically if you see in this 3 by 3 matrix, right? So we have filled this 1 1 3 1, that row, and 1 1 4, this is the first row and first column, right? That we have filled. So we will start the processing from this 5, right? So that is what we are going to do. So in order to calculate the minimum sum there, what we are going to do is the minimum of sum of I j minus 1 plus grid of ij, or sum of I minus 1 j plus grid of ij, whichever is the minimum. So whatever the sum obtained from here or here, you add this sum to 5 and this sum to 5, whichever is the minimum, that will go in here. So that is the logic that we are using. Sum of ij is equal to math dot minimum of sum of I j minus 1 plus grid of ij, or sum of I minus 1 j plus grid of ij. Any of them, whatever the sum, the minimum, right? We are going to take that and put into sum of ij. So this will be executed from cell 1 1 to m minus 1 and n minus 1th cell. So finally whatever the sum that we obtained at the m minus 1 and n minus 1th cell, you are going to return it. So let's go look at the time complexity for this algorithm, right? So here this for loop is going to take order of m, and this also is going to take order of m. So order of m plus order of m, so it will be still order of m. So this will be order of n, so order of m plus order of n here, right? And this one we will be executing these two. This loop is order of m minus 1 into order of n minus 1. So since we are just trying to subtract minus 1 from m and minus 1 for n, right? When m and n are typically large, m minus 1 into n minus 1, it will be equal to m and n, m into n, right? So we would say the complexity for this code is order of mn. So overall, if you add up order of m plus order of n plus order of m into n, right? So which will be equal to order of m into n as the total worst case complexity, right? That is the time complexity. Let's go look at the space complexity for this. So space complexity is also equal to the order of mn, because we are using the sum array to calculate the minimum path sum, right? So we are declaring the sum array to be equal to the order of m by n. So the space complexity and time complexity both are equal to order of m into n. Hope that clarified all the questions that you might have. If you still have any more questions, please put them in the comment section. I will respond back. Thank you for watching. Please subscribe to my channel if you haven't done. Please click the bell icon so that you will be notified with all my future videos. Also, share among your friends. Thanks for watching. I will be back with another video very soon. Till then, goodbye.